Hello, everyone. We will start in a minute, see if more people connect. So welcome.
Thank you. Happy to be here.
You're welcome. Is this the first time for everyone using Python, or you wanted to learn, but you wanted to know a learning path? Answers are welcome.
I have taken some courses before with Constellate, which works with digital humanities.
Mhm.
But I just wanted a little refresher, and also to, in the context of our university. So thank you for offering these.
Okay, well, anyone else? This will be a Python refresher, or you're looking to use Python for doing data analysis, machine learning, any type of data science task?
I have
Okay,
very limited experience with Python, so
okay.
yeah.
And you use what, R, or you use other language programming?
Nothing at the moment.
Okay, Excel, please.
Yeah, exactly.
Okay, all right. So let's start a little bit. So my name is Carlos Lizárraga. I'm an educator here at the Data Science Institute and also part of the University of Arizona Data Lab. And we run these type of workshops every semester during the first part of the semester, because then later everyone is busy doing some other stuff. So okay. So I'm going to share in the chat the notes for today, and let's see. You can always start from the Data Lab GitHub page. Let's see. Let me share my screen. Share. Okay, so this is the landing page for the Data Lab. It's on GitHub, so it's ua-datalab.github.io. And this is where we keep our resources, our learning resources gathered for everyone. I'm going to put it in the chat. So UA. And we have several trainings running every semester. So right now we're running about 6 workshops every week. And some workshops like this one runs every 2 weeks. This will be a very good page for learning resources about data science. And this is what we actually do. Some of our workshops are hybrid, so you can go to the science library room 212, or some workshops are only via Zoom, like this one that runs every other Wednesday at 1 p.m. So you have the Zoom, and this is the list of different workshops we are running. Okay. Okay. And these are the workshops that we are running this semester. Everything is focused on AI and machine learning and bioinformatics, and also for how to use our U of A cloud infrastructure like Cybers. We have Cybers office hours running every other Friday. We have the data science tapas, which are just regular data science, general data science talks, and how to use some tools like today. And we have functional open science skills for AI and ML. Also, we have a workshop on AI foundation models. if you're interested in large language models. We have a workshop on NLP and also a workshop on project management. And you can find some other previous workshops and learning resources if you are interested in AI for healthcare, or data engineering, or deep learning, or graph machine learning, introduction to data science, which is today's session is going to be one of the lectures from Introduction to Data Science. Neural networks, next generation geospatial, prompt engineering, etc. So today we're going to go into the introduction to data science, and we're going to pick the lesson for introduction to Python for data science. And I'm going to post the link in the chat for everyone so they can follow. Let's see. Okay, today's session. Okay, so this is going to be an introductory lesson, and basically is to introduce to you what is Python and how is it used in data science. And Python is a programming language that is very popular. Actually, there's a site that tracks all the advances of each programming languages, and this is one of the most popular languages. And it's a general programming language, and it's used for not only data science, but for example, for running probably autonomous vehicles and any other type of deep AI or deep learning application. So it's very popular. But if we focus on just doing data analysis, then Python has a collection of different libraries, let's say it like that. So you can use specific libraries to do specific tasks. For example, if you want to do a data analysis in general, and you have a data set or a spreadsheet or an Excel sheet, then you can use pandas for doing the data analysis. And by doing data analysis means that you can compute all the different parameters like statistical averages, standard deviations, find outliers, and train other models to do visualization. So in visualization, Python has more than 10 visualization libraries, but these are the most important because Matplotlib was the first one, and everything has derived from that library. Seaborn is just a derivation of Matplotlib, but it's easier to use. It's more user-friendly. And for example, if you are coming from the R programming world and you are used to use ggplot to make visualizations in R, then Seaborn has similar libraries that run on Python, but they have the same syntax as ggplot, and that's called plot9. And then if you want to do more scientific stuff, like doing numerical simulations, then we have, or mathematical operations and functions, we have numerical Python, which is called NumPy, or scientific Python, for example, if you want to, or you have a task of trying to solve a set of linear equations, or you want to find compute the area under some specific integral, or you want to do solve a set of differential equations, etc. So this is scientific Python. It's just a collection of algorithms in Python to do specific tasks also. And then we have the world of machine learning. And in machine learning, we have two types of machine learning. The classical machine learning, where you can use specific algorithms for doing regression or classification. You can also do cluster analysis, or you can train models to predict some label, etc. So it's a whole new universe of different types of problems. And Python is the base programming languages that is being used. Please stop me or just put any question in the chat as I go, so don't wait until the end. So this is my goal today, to present a series of Python resources so you can track. And I'm going to go, before I start talking about more about Python, I will show you other types of learning resources that are on the end of this page. It's going to be very long, but if I go to the end, you will find more references. And we have tutorials. There are tutorials about Python. And then we have all the collection of workshops from the Data Lab, Introduction to Data Science. And this session is only one of the sessions over there. And we have a digital library where we have been collecting a series of Python books. Let's see if I have it here. Yes, so go here to Python programming, and all the list of all the books that appear here are digital, so you can just browse and probably select one or two to study more Python in detail. So if you like learning from books, these are the books. And if you like to learn from courses, then there are several resources, learning resources over there. So you can find them at the end of this page. And also you can find all the previous U of A Data Lab workshop series about Introduction to Data Science. Okay, so let me go back to the beginning of this file. And this file is, or this session is designed to go over an hour. So I'm just going to show you a part of it, and then you can continue exploring it. Okay, so this is the list, for example, of some basic Python libraries. I mentioned NumPy, SciPy, and Pandas. And then there's other libraries like Polars, which is designed for when you have large data set or spreadsheets that have more than 10,000 lines or maybe 100 lines, then you use Polars. For visualization, use Matplotlib or Seaborn. And if you're going to do machine learning, you can use scikit-learn. Or if you're working with images, you can use scikit-image. If you're going to be doing something like deep learning, neural networks, you can use TensorFlow or PyTorch. And if you're more into natural language processing or large language models or machine translation or computer vision, you can use Hugging Face. Hugging Face is just a library of different models where people can download the models and do some specific deep learning or machine learning task. And then there are other libraries like OpenCV and YOLO, which are more used on computer vision and image segmentation. So Python has, it's an open source software. It's interpreted, and it's since it's open source, the Python programming community is very large, and every people or every group has designed different libraries, so you will find lots of resources about Python. Okay, so how can we work with Python? There are two ways. One way is working locally, like installing a program on our computer, and there is a suite of Python programs which is called Anaconda, and we can download that program into our computer, and it's free for academic purposes. So you can have it Python installed locally, or if you're working on a computer that is your office computer, or you share that computer with other persons, maybe you want to work in Python using the cloud. And there are several ways of working with Python on the cloud. One would be if you have a Gmail account, you can use Google Colab, which is very good for learning Python. Or if you're going to be doing something more serious in data science, you can use the cloud computing infrastructure at the U of A. One is Cyberse and the other one is HPC. And if you are more into more, you need more computing resources, then there are some other options like Jetstream, which is NSF funded. So you have two ways of working with Python. Offline, you install everything on your computer, or you can work online. And for our purposes, we will be working online. And to work with Python, we need an interface, and that interface is called Jupyter Notebooks. And it runs on Google Colab. It runs in many other sites, but this is the basic programming environment we're going to be using, and it's very easy to use. It's a notebook, means that this notebook will have some cells, and in the cells we can write code or we can write text. And I'll show you one example. All right. So before I start talking about the pieces of Python which follows, I'm going to jump and open the the Jupyter Notebook in Google Colab. So if you click on this link, it will take you to a Jupyter, to a GitHub site where you will find this Jupyter Notebook. And Jupyter Notebook here is over on our GitHub site. And the Jupyter Notebook, although is Python, interactive Python notebook, this file is interpreted by GitHub, so you can see it. This notebook, you can see it with pieces, segments of text and segments of code. Okay, so this is just a file, and then I can open this file in Colab. So what you can do is get to Colab. So if you type look for Google Colab, search for it, and please stop me. No, Jupyter Notebooks is included in Anaconda Python, as well as Jupyter Lab. Jupyter Lab is the advanced version of Jupyter Notebooks, but in general, we talk about Jupyter Notebooks. But today, we're not going to install anything. We're going to just look for Google Colab or Google Collaboratory and use our Gmail account. Everyone frequently has a Google Colab, and then it will open the site, and then you will create probably a new notebook. Create a new notebook, right? And you can open a notebook that is sitting over GitHub. So this is a good place to start and copy the address of this Jupyter notebook over GitHub. Copy this direction, this address, and paste it over here. Once you open it with Google, with GitHub over here, so you paste the address. Okay, you have to enter what? Oh, just GitHub. Let's see. Here you paste the whatever U of A. That and um, but going to be all these. Well, let me see how it goes. let's say if you try to open it in Google Colab, it will say something, and then you authorize GitHub, and then you connect, and at some point you open this Jupyter Notebook in Colab, which I have it over here. Okay, so this is the short introduction to Python. So here are the text cells, and if you are familiar with the Markdown language, you can type texts. So if I use a pound sign, it's going to be a title. If I use double pound sign, it's a subtitle, right? And so then if I want to have like a list of things, so item 1, item 2, and on the right you will see how it's displaying. So on the left hand side I have the Markdown language. It's called Markdown. Okay. And it's very popular in R. Also, you use R Markdown, or if you use Quattro, which is another publication software from POSIT, which was R Studio, and this is Markdown. So, and once you finish, you just say Shift Enter to process the information. Okay. All right. So we continue. So we have text, and then this is a piece of code. This piece of code is Python. So I'm going to make my font a little bit larger. So numbers in Python. I have a variable here called x, and I'm going to give the value of 5 to this variable x. So I'm defining. See what. Okay, so I'm defining x equals to 5, and then I will ask Python, tell me, print, what type of variable is x, and then I will print the value of x. To execute, this is a Jupyter Notebook, so I can just push the play button, and it will execute. Oh, yes, a warning because it was not mine, and I say yes. Okay. And then it's running, and it printed this 5 is this part, and the previous line is class integer. So x is an integer, and in many programming languages we have different types of numbers. We have integers, we have floating numbers or real numbers, and then we have other types of variables like Boolean, like true or false. All right. To perform arithmetic operations on a numeric variable is very simple. So I'm going to add 1 to x. Remember that x was assigned value 5 and it's an integer. So what will be the result of 5 plus 1? It will print 6. Or I can print 5 minus 1, which will print 4. So I execute this. So I have 6 and 4 respectively. Okay. I don't have to say anything what was x, only define what was x, and that's it. And then I can multiply x by 2. So since x equals 5 plus times 2 will print 10, and x squared, it will print 5 squared, which is 25. So got it, right? And if you want to add more code cells or text cells, you just push this or select these buttons, and it will create a cell wherever your cursor is. Okay. All right. What else? What about printing something more, a more complex expression? So if I have x plus 1 plus 3 times x. As in many programming languages, there are some operations which are executed first. They have priority. So the multiplication operation has priority over the sum. So I'm going to multiply first x by 3, and then the result will be added to 1, and then x. So the result will be 3 times 5 is 15, plus 1 is 16, plus 5 is 21. And if I do it this way, the result is different. The parenthesis encloses the priority. So 3 times x, I enclose it in parentheses, it will have priority. But I know that the multiplication has priority, so this is 15. And then x equals 5 plus 1 is 6. So 6 plus 15 will be 21, right? And then I execute, and I have the same thing, okay? Any questions? Am I going too fast? This is the first time you use Jupyter Notebooks, or you are familiar with Jupyter Notebooks? Yes, no? Okay, all right, so we continue. For division operator, it's going to be similar. Yeah, if let's say I'm going to add here for example, I'm going to add a code cell. And division, if I say, okay, how much is 1 plus 3 divided by 2? What will be the result? So the division as the multiplication has priority. So 3 will be divided by 2. And then I will add 1. Okay. But if I'm strict, 3 is an integer number and 2 is an integer number. So I cannot divide 3 by 2 and have an integer. But Python will fix everything. So the result will be a floating number. So I execute here, and I have 2.5. So all my integers were converted to real numbers, and then get the result. There's another division operator, which is called this division. So this division is among integers. So how many times does 2 fit inside number 3 as integers? I think only 1, right? Plus 1, my result will be 2, because this is the integer division, and this is double. The double division is an integer division, and this is the real division, just dividing real numbers or floating numbers. Okay, we can continue. I assign now x equals to 7, and then I'm going to I have it in the same expression. I have x on both sides of the equal sign. So this is the equal sign is more like an assignation sign. So x equals, when I execute, x will be 7, and then I subtract 1, that will be 6, and then 6 will be assigned as the new value for x. So x started as 7, but when I subtract 1 from 7, I get 6, and 6 will be the new value of x. So when I print the value of x, I'll have 6. So you can use this operation is read from right to left. So I do first thing the right hand side, and then I assign it to the left hand side. Okay, that's how it works. There's another way of writing this operation, and I can do it like this way. So this is more like a short notation. Means whatever is x, I'm going to subtract 1 and then assign the value, the resulting value to x. So I get the same result. So it's equivalent. This short notation is equivalent. So this is the short notation. Okay, so Python so far has behaved like a calculator for doing basic arithmetics. Here I divide 5 by 2, so now it's 2.5, and then initially y will be floating or a real number, and then I will print different values, y plus 1, 2 times y, and y squared, so I get this result underneath. Okay. So far so good. Integers, floating, all the arithmetic operations we're familiar with. What about Boolean variables? Boolean variables are the two values, true or false. Something is true or something is false. Cannot be both. So if I define t as true, notice that true and false are written with capital letter. So if I print the type of t, it will say that is a Boolean variable. And if I ask, tell me what is t and f at the same time. So this is and. So since t is true and false is false, both cannot be true. I'm just playing with logics. Okay. What? Okay. And then this is logics. If the two variables are true, and I say if this is true and this is true, then that the result will be true. But if one is false and the other one is true, it has to be false. If it's true or false, then it's going to be one of them is true or one of them is false, then it's going to be true. And negation of true will be false. And this is the another XOR, which is just different. If true is different than false, it will be true. Okay, that's just logics, how logics will work. And then we can go to strings. So strings are just a string of characters. For example, hello, I enclose this between quotes. So this is the hello. And the variable is called hello. And this is the string. So a string is just the sequence of words. And then I have another string, world, and the string is world. I can use double quotes. Then I can say print hello, or print hello will just print hello. And if I print hello is a string, len is the function that counts how many, what's the length of the variable. So in this case, hello is a string, so it has 5 letters. So it will print 5. The length of the string hello is 5, has 5 letters or characters. And then I can combine the hello. If I have the variable hello and I add the variable world and I add a space between them, it will print hello world. Okay. So if I execute this, I will get what the result that I had before. The last one was print the value of hello, which is hello, to the entire, and then print the value of the variable world, which is world, exclamation, and I have hello to the entire world. Okay. I can, if I have this variable cat, which stands for cat, and then I can capitalize cat, so it will convert the first character to uppercase. And then also I can count the number of strings in cat. So okay, the substrings in cat. So it has to print the number of substrings. Okay, let's go to the basic arithmetic in Python. We have seen all the standard operations. We saw that the integral division, and this is the modulus. If you are familiar with algebra, it just gives you the residual when you divide two numbers. Floating operators, these are the standard, plus addition, subtraction, and then you have the division, and this is the multiplication and the power. Boolean expressions, true, false, equality. So when you ask if something is equal to something, you have to say, use the double equal signs. Not equal, just exclamation equal. This means not equal. Greater than. So these are just logic operation. Is 5 greater than 4? It will tell you true. Is 5 different than 5? It will tell you false. Is 5 equal to 5? It will return true. And then the same thing applies to the less than or the less equal than. Or you can, you have these other operators, and, or, not. Okay. And if we have two variables, x equals 2 and y equals 7, then see if x equals y, it will return false, because 2 is not equal to 7. And then is 2 different than 7? It will return true. And then is 2 greater than 7? And it will compare the two values and return false. So when I execute this, I get those results. Okay. So that's the basic algebra operations. And then now we expand from our variables besides numbers and Boolean variables. Then we have lists, and a list is just a collection of elements. And in this case, the list is denoted by the square brackets, and you can have like integers 1, 2, and a real number or floating number 3.0 and a 4. And I have another list, 1 point something, that's 1.0. We have 2 integer, and I have 3 between quotes. This is not a number. This will be just the character 3 on your keyboard. And this is the number 4, the integer number 4. And then I print the list 1 and the list 2. And then I will try to combine. I will try to add list 1 plus list 2. And then it will add, since this is a list, it will just append the second list after the first one. So there is what when I sum two lists. So these are not, I'm not summing numbers. I'm just adding one thing after the other, and we can consider lists as things, right? So I cannot do any arithmetic operation because it's a list, right? And then we have tuples, and tuples is just a collection of variables. So let's say a tuple is equal to 5, and then I'm going to define D, which is, I'm going to use the function range. So range is just the values from 0 to 9. And then I'm doing a for loop. So for x for x in range. So whatever range is, which is 0 to 9. So for any x from 0 to 9, I will just add the numbers. And here I'm just creating a tuple. So I'm calling it T. So this is just a couple of numbers, 5 and 6. And then since I'm using the round parentheses compared to list, which I was using square parentheses, this is a tuple, and then it will tell me I can find locations of. So this is just like a collection of things, right? Then I have sets, and I have a list one, and I have a set, which is, I'm using the curly brackets. So for list, I use square brackets. For sets, I use curly brackets, and then I can convert uh, to a set. A list, I can convert a list into a set. So here I will have two sets. And the second set was just using the function set applied to a list. Okay. And now I have the curly brackets. Okay, so in Python, we have many types of objects. So we have the basic integers, floating, which are numbers, logical variables, Boolean variables. I have lists, we have tuples, we have sets, we have dictionaries. Okay, it doesn't matter we don't use it right now, but just the general overview. We can do conditionals. For example, if x equals 3, y equals 2, and z equals 1, then I ask if x equals y. So is 3 equals to 1? If it's true, it will print hello. If not, if x equals 1, or if 3 equals 1, it will print goodbye, so it's not true. And if nothing else, try again. Okay, so what would you think it will happen here? What will be printed if I do it? The first condition obviously is not satisfied, so it jumps to the second condition. The second condition is 3 equals to 1, is not satisfied, so it jumps to the next one. It will print, try again, right? What if I change here? If I say c equals to 3, what will happen? The first one is 3 equals to 2. Nope. Is 3 equals to 3. Yep. So it will print this one. And then it will just forget about the next step because the condition is satisfied. So those are the conditionals. We have loops, something that can be used to do an iteration or repetitive operation. I will just leave it like that.
Carlos, in some of the operations above, you use a small f, and some you don't. What is the f doing?
Where? What exactly?
Further up, if you look at the next one above. So the
Okay.
small f.
So this F is just format. This F is format, and let me see. Yes, this F here
Yeah.
is just a format. So we'll print list of keys, just a text, and then it will print the function list and whatever value of the keys is. So it's just a print statement. You can see here the phrase list of keys, semicolon, list of keys, semicolon. So print F, comma, then you close whatever that comma is going to print the text and the values of the variable. So if I can say, let me see here, yeah, the code, if I say x equals 5, and then I say print, and then I use parentheses, and then I say format, and then inside the format, I will say, okay, Friday is the number 5. Number 5 is the day number 5. So number, then I'm still writing text, and then I have to say, tell me what is the value of x. So let's say if I say, well, I just say type x. X is a variable, right? So it should work now. No, I need to finish this. Save. I think I need a dollar sign here. No. Here's like this, comma. Okay. Yeah. So it's just a format to write a phrase in between quotes. And then this, since X is a variable, I have X explicitly, it will just dump the value 5 over here. So F is just a format. Similar to what you use in C programming language and other. Okay. Right, we continue. Okay, so these are loops. Loops is just to do something iterative. There are several functions in Python. Range is a function. Since it just have the number 5 over here, it will just have from 0 to 4. In Python, you start counting with 0, from 0. So you never count 1, 2, 3. You start 0, 1, 2, 3. So just be aware of that. So here for I in the range 5, so this is 0, 1, 2, 3, 4. For one element in 0, 3, 3, 4, just print the value of that element. The second one, I'm doing a reverse range from 10 to 2, every 2 steps down. And then in this place, I start with I equals 1, and then while I is less than 10, I will just print the next value of I, and this is just a loop because I increase the I every time the loop runs. So I can do that, and I get the first result, which is the loop 0, 1, 2, 3, 4, which is just a range of 5. And the second loop, I print from 10 to 2, the decreasing numbers. And here I'm just printing the next number. I started from 1. And since 1 is less than 10, I will print the next is 1. And then it will just increase every time it's looping or iterating. It will increase the I by 1. So I will be increasing the I and printing that value. Okay. All right. Okay, so that's basic mathematical operations. Then it's NumPy. Okay, so what if I want to use special functions like trigonometric functions, square roots, logarithms, etc.? Then I have to use NumPy, and NumPy handles more than numerical variables, also has arrays. So arrays will be like the lists, but now arrays are strictly numbers. Lists were just a list of, like a shopping list, but an array has to do with numbers, okay? And so this is an array of integers. This is an array. So 4 is a real number or floating number, so the other integers will be converted to float. In this case, 4 is just a character, so it will be converted to 4, right? And I'm sorry, in this case, since 1 is character, then I have to convert everything else to character. So the output is this one. So since 4 was a character, the other ones are just characters. And in the first place, everything was integer. The second line was, one of them was floating, so everyone else is floating. And in the last one, I have an range, which is another function. It's just, it will create an array from 0 to 5 every 0.5 values. And the other function is linspace. I can create an array from 0 to 5, but with 20 points in them. So this is the result. I didn't print. Okay. I didn't print. Okay. So shift enter. Oh. Yes, I didn't run this. So I need to load the NumPy library, and the alias is NP, and then I can use NP as NumPy. So array is a function of NumPy. Array range is a function of NumPy, and linspace is a function of NumPy, and then I can use them. Okay. Okay. I can add two numerical range. I can add two numeric arrays. So I can add S1 plus S2. So this is S1, and this was S2. I can add them, and I can print the result. Now, since all the arrays are just numeric, it will do the arithmetic operation of summing element-wise. So 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6, and 4 plus 4 is 8. And in the other one is 5 times S2, so I just multiply element-wise by 5. 5 times 1 is 5, times 2 is 10, times 3 is 15, times 4 is 20. So that's an array. So I can just multiply an array by a number or just sum the different arrays. Okay, I can access the elements of an array with an address. So if, for example, my array is 1, 2, 3, 4, remember Python starts counting from 0. So 1 is the 0 element, 2 is the first element, 3 is the second element, and 4 is the third element. So if I print the second element, it's going to be 3. And if I print, I can print a range from 1 to 3. So remember from 0, so the 1, 2, 3, this is the first one and the second one. Okay. The same thing applies to this is one-dimensional arrays. I can have multiple. This is a two-dimensional array, 0, 1, and the other array is 2, 3. So I have an array of 2 dimensions, and this is a 3-dimensional array. The array 4, 5, 6, and 7, 8, 9, and 10, 11, 12 is the third array. So I can do that. Okay. So so that's the way you have been working with arrays. I can select specific parts of an array using slicing arrays. You just need to remember that you can count. You start counting from 0. Okay. I have to finish in less than 5 minutes. Okay, so these are other examples of sums, divisions. What else? Okay, this was an example. This is an example. You can do it by yourself. Okay, so that is my running example, and it's this one. Okay, but I have notes and notes for more content from Python that you can review. And remember, you always have access to different learning resources. You have the tutorials, we have the books, and we have other learning resources. Okay, so any questions? I know that this is maybe too much, but it gives you a general overview of what is Python, how to use it, and how can you use it for using data science. Any questions? There's going to be a recording of this. It will just, we have We have a YouTube channel. You can find it in the, let's see. In the data lab. So here. When we post all the videos from the lectures in this YouTube channel. So you can go back or explore different videos from previous workshops. So you have always access to these different resources.
Great,
So,
thank you, Carlos.
Well, thank you for connecting and see you in 2 weeks, or you can just go to our events calendar and see what workshop we have every week. Okay. So thank you very much for connecting, and I'll see you soon in some other workshop. Thank you.
Thank you.
You're welcome.